My dear student, today I will be talking about SAR model of COVID-19. This is the starting of Unit 3. Unit 3 is all about mathematical modeling of diseases or population of species. So we'll be talking about today. The hot topic of today's hot topic is COVID-19. It's a pandemic condition. Mathematically, we will explain what is the pandemic condition of COVID-19 using SAR model. So there are lots of model. So we will be studying this SAR model. So SAR model, it is all about we divide the whole population into three categories. One is susceptible, another one is infected, another one is recovered or dead. So this is the scenario. The whole population is divided into three categories. This is the whole population. This is susceptible, this is R, this is R, and this is I, and this is your S. So initially, in the initially starting point, the pandemic already happened. The pandemic now it is already happened. So that means there are some infected people. Initially, some people are infected. The I not initial. So there is no recovered. At the start of the pandemic, there is no recovery. There is no death. Just infection is there. And then the initial, after taking out the whole population is susceptible. After taking out the infected one, the remaining are susceptible. Okay, so S naught and I naught, this is total population. And the first assumption is that this total population is constant. This total population is constant. That means at any time total population is constant. So as time changes, this susceptible population, it is also changing, and then the infected one is also changing, I, then the recovered or dead one is also changing. So this is constant all the time. The sum of these three categories of population is constant, that is S naught plus I naught. This is constant. Okay, this is first assumption. And another assumption is that if if these people is if this much people is infected one, all right, so then there are two possibilities: either they are recovered or they are dead. Okay, so if they are recovered, then these people are, the recovered people are are not susceptible by the disease again, by the virus again, because they have developed immune system in their body. So they are not susceptible to the diseases. Okay, that means first, as time goes on, the number of infected people are increasing. So the infected people are subtracting from the whole population. That means the population which is susceptible to the virus or to the disease is decreasing. So that means S is decreasing, I is increasing, and R is also increasing. All right, so this is the condition. This is the assumption we are going to make. And the rate of infection, or the rate of infection, the increase of infected people with respect to time, that is rate of change of I, is directly proportional to the context. The context means, suppose there are I infected peoples and then S susceptible people. So we are assuming that this is a total contact. IS is a total contact. All the whole population, they are susceptible. So theoretically they are all are possible to contact each other. So total contact is IS. So the rate of increase of infected people is directly proportional to the context, total context. IS is the total context, and R is the transmission rate between the contacts. Then di by dt is equal to this much. All right. So but we have to from the increase in the rate of increase infected people, you have to subtract the what? You have to subtract the rate of recovered or dead one. This is the total rate of increase of infected people. All right. And rate of increase in fact this one recovered or dead one, this is directly proportional to the number of infected people with a proportionality constant I. All right. So this is the rate of increase in recovered or dead people. So this equation, and the first another one equation is the rate of increase or rate of decrease in. I already told you the susceptible population is decreasing, so ds by dt, this is rate of decrease. So since it is rate of decrease, so there will be negative, this derivative should be negative, and it is directly equal to the rate of the contact transmission, RIS. So these are the these are the fundamental things. What are the fundamental assumptions we are making? The total population at any time is fixed, is constant. All right. And then the rate of change of susceptible population is negative, and it is proportional to the context, total context. Total context is IS. If there are, say for example, if there are 5 people infected, and if there are say 10 people, so total context 5 and 10 is 50, right? So total possible context is 50. So this is total context, like that. I number of infected people are there, S number of people are susceptible, so total contact is IS. Okay. So the rate of change of susceptible people, it is directly proportional to the direct context, and then we have to multiply by the proportionality constant R, and since it is decreasing, it should be negative. Okay. So ds by dt is equal to minus RIS, and rate of change of infected people, this is also directly proportional to the total contact multiplied by the the transmission rate or proportionality constant, and then from the rate of increase, so there you have to subtract the rate of recovered one or dead one. So people are infected, they are either recovered or they are dead. All right. So those amount you have to subtract, then you get this di by dt is equal to this formula. Okay. And rate of recovered is directly proportional to the infected people with this constant of proportionality. Right. So this is the idea, this is the central idea, and this assumption, the 3 assumption we are making, that is the first assumption is the total population is constant at any time, and number of infected is directly proportional to the number of contacts. Okay. And then number of change in recovered or dead one is also directly proportional to the number of infected people. So these 3 assumptions we are going to make in SIR model or SAR model. Okay. And then we derive this equation. These are the governing equation of the pandemic. Okay. So from this we are going to derive the condition for pandemic to happen. Okay. So let us go back to our note then. So this is the explain the pandemic condition of COVID-19 using SAR model. So as I told you, the total population is divided into 3 categories. The first category is susceptible one. Everyone in the population, they are equally susceptible to the virus, because the virus is very dangerous one. It is novel coronavirus. So everyone without caste, creed, sex, all community, all human beings are equally susceptible to the disease. And then I represent the number of infected people in the population, and R represent the the recovered one. One fundamental biological assumption is there. If I people are infected, okay, either they are dead or recovered. So after recovered, those recovered people, they are not susceptible because immune system developed to their body. All right, immune system developed to their body. So infected peoples are not susceptible. Okay, so that is the another basic thing. We are going to assume that one. So then the basic assumption of SIR model, every mathematical modeling we have to assume some basic fundamental things happening in the real world. So in this COVID-19 pandemic, the reality, the three basic thing we are going to assume this one, three basic points, and then we are going to translate these things into a mathematical equation, and then we study, then we find out the pandemic condition. Okay, so the first condition, the assumption is that total population at any instant of time is constant. Okay, that means we are going to assume that the pandemic is happening in a very short time, because if the pandemic is for 10 years 20 years, so population is not constant for 10 years 5 years like that. So population is constant for maximum 3 months 4 months 6 months like that. We are going to assume that one, and then at any instant of time the total population S plus I plus R is equal to constant. At the initial time, S not number of people are susceptible and I not people are infected, so there is no recovery things in the first time where the pandemic happens. There is no people who is recovered or who is dead. All right, so this is S naught plus I naught is constant. Then the rate of infection is proportional to the context. The rate of infection is proportional to the context. So as I already told you, if there are 5 people are infected, 10 people are there in the locality, just for a sake of understanding, then what is the total possible number of contacts? 5 people into 10 people, 50 contacts are there. So if there are more contacts, then the infection rate is higher. Okay, so that is the thing. The rate of infection is proportional to the context. Okay, and then again the rate of recovery or recovered is also proportional to the infected people. Okay, if there are more infected people, so there will be more people recovered or more people are dead. Okay, so that is quite obvious. If number of people are more, infected number of people are more, then the recovered is also more, or dead people also more. Okay, so these 3 basic assumptions we are going to make, and then we are going to derive the equation. So as I already explained in that pen window, that the differential equation governing the pandemic is given by these 3 equations. First, the rate of change of susceptible people, susceptible is equal to minus RIS. Why minus is here? Because as I already explained that as time goes on, the number of susceptible people are decreasing, so that negative signifies that it is decreasing. So this derivative is negative, means S is decreasing as time goes on. Okay, and then the rate of change of infected people is equal to, it is also proportional to the context, that is this much, and also you have to subtract the number of recovered or dead one. Okay, so this is the equation number 2 governing the the rate of change of infected people. All right, so and lastly, the rate of change of recovered or dead one is proportional to the number of infected people, and A is the proportionately constant. All right, so where R is the constant rate of infection and A the constant rate of recovered. Okay, this constant R and A will play vital role to determine the pandemic condition. Okay, and one more thing, also this is the recovered one. If you want fast recovery, so that means what? If less people are dead, or you want to make all the infected people are recovered, then what medically what you have to do? Medically you have to have drugs, treatment, okay, or vaccine. But for the time being, we don't have any standard treatment, drugs, or any vaccine. So this constant A, we cannot do anything in this constant A, because this constant A is directly related to the treatment or to the vaccination. Okay, so these two front we don't have any help. Okay, we don't have anything to cure the disease. Only thing is that those people who are healthy, their immune system are strong, they can fight back the virus and they can survive. We don't have vaccine, we don't have drug. Okay, so this A, we cannot touch anything, we cannot change it. But this transmission rate, this is the vital point where we can do something, because transmission is really happening because of context. So that is why we are government are advising to give social distancing and to give self hygienic, like washing of hand regularly with hand sanitizer, or not touching our mouth, nose and eyes by hand, like that. So those are the things to minimize this R. Okay, those are the things to minimize this R. So that is the only thing we are having nowadays. That is why lockdown is important. Okay, those things will be revealed by this model later on, but I just highlight what is happening. Okay, so let us see. The first assumption says that it is also obvious from this equation, if you sum up all these three equations, it is 0, because this one cancel out, and this one cancel out. Okay, so that means d by dt of s plus I plus r, that is the total population at any time, is equal to 0. So that this is 0, mathematically what we say, that this is constant. So constant means what? In the beginning, the total number of population is s naught plus I naught. This is equal. So s plus I plus r is equal to s naught plus I naught. All right. So again, from this equation, there is no fixed point or equilibrium point, because why? In order to have an equilibrium point or fixed point, ds by dt is going to be 0, but I is never 0. The pandemic has already started, so I naught is there, s naught is there. They are not going to be 0 at any time. Okay, so that means there is no fixed point, there is no equilibrium point. So similarly, this one cannot be 0, this one also cannot be 0. So there is no fixed point, there is no equilibrium point. So there is no fixed point or equilibrium point as the pandemic already started, and that is people already infected, I naught is not equal to 0, and people are already susceptible, because the virus is very dangerous. They can infect anybody without without differentiating any caste, creed, color, sex, all these things. Everyone, women, men, black, white, European, Asian, all these people are equally susceptible by the virus. Okay, so from the equation number 2 we have, so equation number 2 gives, what does the equation number 2 says? It is the rate of increase of infected people. That is the concern of the health system around the world. The rate of increase of infected people, we want to lower this one. If we are able to lower this one, then we can control the pandemic. So it is the first thing is to investigate this equation. From the second equation, let us see. From the second equation, di by dt is equal to IRS A. So putting s, and in the beginning, susceptible was s naught, and this is the highest. As time goes on, I already explained you, as time goes on, the number of susceptible people are decreasing. Okay, so maximum susceptible people is s naught. So let us put here, let us plug in the value of maximum susceptible value here, then you will get this one. If this quantity is negative, if it is less than 0, if this quantity is negative, so di by dt is negative. Okay, so di by dt, this one will be decreasing, and the maximum value will occur when s becomes s naught. So at any instant of time, di by dt will be less than this quantity, and if this quantity is less than negative, that means di by dt is negative. So mathematically, if di by dt is negative, that means what? Instead of increasing, the infected people are decreasing. That is what we want to control. If di by dt is negative, then the infected people are decreasing. That is what people all around the world talking about, flattening the curve, all these things. That means you are making infection rate is making it is decreasing, the flattening of curve, all these things. This terminology you might have heard around the world. Okay, this is the this is the idea. Di by dt is, if it is negative, then the number of infected people is decreasing. So that is what you are controlling the pandemic. All right, so if it is positive, that means di by dt is increasing, that is the pandemic is out of control. All right, so how to control the pandemic is, the basic idea is to make di by dt is negative. Okay, so then let's see. So the pandemic condition is, the pandemic condition is this term is positive. Rs naught minus a is positive. If it is positive, the rate of infection is increasing, so pandemic is there. Right, so when it is negative, Rs naught minus a is negative, then we can control the pandemic. That means the infection rate is decreasing. So this is the this is the thing. So how to make this negative? That is all about the the possible ways and the means to make di by dt negative is all about the controlling the pandemic. Okay, so let us see. For the pandemic case, what happened? For the pandemic case, we have so from here, after simplification, s naught is greater than a by r. So if s naught is greater than a by r, the pandemic case happened. That means this is positive, this is going to be positive. Okay, so s naught is greater than a by r, and a by r, let us put a more simplified constant 1 by q. Okay, then q will be r by a. So q is the, we call it contact ratio. All right, the contact ratio. Okay, so that means what? After simplification, pandemic will occur, or pandemic will happen if s naught times r divided by a is greater than 1. Okay, and let us replace this constant or this parameter by a new parameter r naught. Okay, this is equal to r naught. So if this is greater than 1, then pandemic occurs. Okay, that means r naught is greater than 1. So this r naught is the reproductive ratio, reproductive parameter, or something like that. So the where r naught is equal to rs naught divided by a, with this is greater than 1. If this is greater than 1, then the pandemic will occur. Okay, pandemic happens. Or r naught is called the basic reproductive ratio. This is called the basic reproductive ratio. That means what? One infected people, how many people are infected? Okay, if in your community one people is infected, so how many people, maximum people he can infect again? Okay, that is the if one infected people infects 2, 3, 4, then so there is chain of infection is there. That is why there is pandemic is there. Okay, so that is one. And q is equal to r by a is called the contact ratio. This is called contact ratio, contact ratio. So finally the things comes down to r naught and q. Okay, and then a constant r and a. So for seasonal flu, for seasonal flu, what happened? the range of R naught, the reproductive ratio is between 1.5 and 2%. Okay, that one infected person can infect another 2%, like that. Okay, so for COVID-19 it is, for COVID-19 is very very big, that is 3 to 4%. So one infected person can infect 3 to 4 more person. Okay, that is coming about from all mathematical data, and that is coming about from the data we are having nowadays. In India, how many people are infected, if there are, so earlier 10,000 people was there, then Delhi increases was around 500 400. Okay, nowadays we have 60,000 50,000, then Delhi increases or infected people is around 3,500 to 4,000, like that. So if there are number of infected people are more, then increase in Delhi increase also increasing. Okay, so from this we calculate that for COVID-19 this R naught is about 3 to 4%. For seasonal flu it is about 2%. Okay, so that is why COVID-19 is very dangerous, and the pandemic is happening worldwide. Okay, so this is all about land. As I told you, to lower this R naught, what you have to do, either you increase A or you decrease R. Okay, so let us go to the window. Your R naught is equal to given by R naught is given by R naught is given by R S naught divided by A. So this S naught, the total population, this is constant, this is fixed, you cannot do anything. And this A also, I told you, this is recovery rate. This, since we don't have any standard treatment, we don't have any drugs to recover, to remedy the disease. Okay, so you cannot do anything in A. You cannot increase or decrease this. This is fixed. The only thing possible, we can change R naught. Okay, if R naught is greater than 1, the pandemic happens. Okay, so the thing is that R, this is the only thing we can manipulate. So what is R? What is the R? This is the transmission rate amongst the contacts. So if there are 50 people infected, if there are 5 people infected in your community and another 10 people are there, so total number of contacts is how much? 50. 5 into 10 is 50. So in this 50 contacts, the transmission rate is R. So if if it is you can reduce this transmission rate. So what is the means to reduce this transmission rate? That means presently social distancing. Okay, so you keep distance yourself from every other people few meters away, so that virus cannot come to you. And then even if you come closer to each other, so you don't touch your mouth, your nose, your eyes by your hand, and also you wash your hand regularly. So these are the means to lower the transmission rate. This is the only means presently available to lower the transmission rate. So if you lower the transmission rate R, then this quantity you can make it less than 1. When you are able to make it less than 1, then R naught, if you are able to lower it, if R naught is less than 1, then the pandemic is controlled. You can control the pandemic. That is why national lockdown worldwide are happening, and then social distancing and a hand sanitizer, all these things, measurement, that is the only thing we can do. There is no vaccination, there is no drugs to control the pandemic. Okay, so that is the what is happening in this pandemic mathematically. Now we have explained. Okay, so ultimately the solution is to do solution is social distancing, and then personal hygiene. All these are the only solution. Later on, if we are able to find a vaccine or drug to cure this disease, then this parameter A, this parameter A, you can increase this parameter. So if this parameter is increased, so definitely this ratio you can make it less than 1, then there is no pandemic. Okay, so this is the explanation of pandemic COVID-19 in the present situation in the burning topic. Okay, so this is very interesting one, so I can ask in the examination also. All right, so this much I want to give you today. Okay, all the best.